This is day 1 of Unit 8. So we started the new unit today, and we started with this warm-up. So take a moment. Should just take you a very quick moment or so. It should not take you long to get the next 3 terms. So hopefully you're looking at that and realizing that the pattern is that we're adding 3 each time to get from one term to the next. So we're just going to add 3 on to 15 to get 18, and 3 again to get 21 and 24. Okay, so then this led into our lesson for today, which is on the beginnings of sequences. This unit involves sequences. So the first thing that we talked about is the fact that this right here, the 6, 9, 12, 15, and so forth, that is called a sequence. And a sequence, you want to write this in your notes, a sequence is a list of numbers that follow a pattern. Okay. Now, there is a pattern here, and we said the pattern is that we're adding 3 to get from one term to the next. So that means this is a particular kind of sequence, which we'll talk about that in just a moment. But before we do that, just some terminology here. These numbers, 6, 9, 12, 15, the numbers that are in the sequence, those are called terms. Terms are the numbers of a sequence. Okay, the numbers of a sequence. So we call 6 the first term, 9 the second term, 12 the third term, and so forth. So there's a notation that we use when we're talking about specific terms of a sequence, and that is we use the lowercase a, and then we have subscripts. So if I'm referring to 6, which is the first term, I call that a sub 1. That is 6. So 9 is a sub 2, you get the idea. 12 is a sub 3, and so forth. So those numbers, when you have a lowercase a and a subscript, that's referring to the specific term number or the placement in the sequence. Okay, so the next thing that we talked about is that sequences can be either what are called arithmetic or geometric. So you want to add that to your notes. Arithmetic means that we are adding a constant amount. So a constant amount is added. Geometric, a constant amount is multiplied. Now, sometimes we'll have a sequence, a list of numbers with some sort of a pattern, but the pattern is neither of those. It's not adding a constant amount or multiplying by a constant amount. So we just say that that's neither. Okay, so we're going to take a look at these examples here, and we're going to decide, is this arithmetic, geometric, or neither one? And then we're going to figure out what the next 3 terms are. So take a look at the first one, 2, 4, 8, 16, and put that in your notes. So hopefully after looking at that, you're recognizing that the numbers are being multiplied by 2. So because they're being multiplied by a constant amount, it's a geometric sequence. So then I'm supposed to figure out the next 3 terms. Well, I'm going to double 16 to get 32. I'm going to double 32 to get 64. And I'm going to double 64 to get 128. Okay, the next one, 0, 2, 4, 6. Put that in your notes. Take a look at that. Hopefully you're realizing without a whole bunch of thought that we're adding 2. So that means the constant amount is being added. So it's arithmetic. And the next 3 terms, just adding 2 on. So that's 8 and 10 and 12. Next one. That one, hopefully you're, well, first of all, copy that. 1, 3, 6, 10. 15, you're probably not noticing that one as quickly. It's not quite as obvious. So when it's not obvious, what you want to do to check to see if it's arithmetic is subtract. So I'm going to do 3 minus 1 and get 2, 6 minus 3 and get 3, 10 minus 6 and get 4, 15 minus 10 and get 5. And those are the numbers that are being added on. Now, I'm definitely seeing that those are not the same number, so it's not arithmetic. And if I divide, 3 divided by 1 is 3, 6 divided by 3 is 2. Those aren't the same number either. So it's not arithmetic or geometric, it is a neither. But I still have to figure out what the pattern is because I need to get the next 3 terms. Well, we wrote the differences out here, and it's 2, 3, 4, 5. Hopefully you're seeing there's a pattern with those numbers. They are 1 away from each other. So I know the next term, to get the next term, I'm going to add 1 more, which is 6, and then I'm going to add 7, and then I'm going to add 8. So when I add 6 to 15, I get 21. 7 to 21, I get 28, and 8 to 28, I get 36. Next, 5, 9, 13, 17. Copy that, think about that. Hopefully you're realizing it's arithmetic. Why? Because we're adding 4 each time. So the next 3 would be 21, 25, and 29. Next, 5, 20, 80, 320. Hopefully you're realizing that's geometric. We're multiplying by 4 each time to get from one term to the next. So after 320, we have 1280. After 1280, 5,120. And after 5,120, 20,480. Next one. So doesn't look like I'm adding a constant amount, but I can check that. 2 minus 1 is 1. 6 minus 2 is 4. 24 minus 6 is 18. Those are what are being added. 1, 4, 18. I don't even see a pattern with those. So now let's check the quotients. Divided. 2 divided by 1 is 2. 6 divided by 2 is 3. And 24 divided by 6 is 4. So those are the numbers that are being multiplied, times 2, times 3, times 4. Hopefully once you've written those, you see the pattern. It's definitely not geometric because we don't have the constant amount, so it's a neither. But hopefully you're noticing that it's times 1 more than the previous multiple. So this is going to be times 5, and then times 6, and then times 7. So the next 3 terms are 120 and 720 and 5,040. Okay. All right, moving right along. Whoops. So we're going to do the same thing here. We're going to determine if the following arithmetic, geometric, or neither. Then we'll do the next step in a moment. So looking at negative 5, 1, 7, 13. Again, if that's not obvious to you, subtract. 1 minus negative 5 is 6. 7 minus 1 is 6. That looks to me to be arithmetic. Okay, next one. 2/5 minus 2, 2 25ths minus 2/5, and you can use a calculator if you want. You would not get the same amount. But if you do 2/5 divided by 2 and 2 25ths divided by 2/5, 2/5 divided by 2, that's the same thing as 2/5 times 1/2, which is 1/5. And if I do 2 25ths divided by 2/5, that's 2 25ths times 5 halves, which is 1/5. So we are recognizing that it is geometric. Okay, now the next piece of the directions say find R or D. So we need to go back a couple slides here to talk about R and D. So a moment ago, I told you that we have either arithmetic, geometric, or neither sequences. Well, if it's arithmetic, remember what I said, we have a constant amount being added. Well, that constant amount has a name. It's called the common difference. Hopefully that makes sense, because if we're trying to figure out what the common difference is, we subtract the one term minus the previous term, and we keep doing that. So common difference, and we use the letter D to stand for the common difference. So it's an arithmetic sequence if you're talking about a D, or a common difference. Geometric, on the other hand, the amount you multiply each time, that also has a name. It's called a common ratio. And again, hopefully that makes sense. Ratio means fraction, which is dividing. Dividing is how I check to see what the common ratio is. I look at a term, I divide the term in front of it. And we use the letter R to indicate we're talking about common ratio or geometric sequence. So back to the problem that we were on. I'm trying to figure out the R or the D. Well, first of all, we said that this first one is arithmetic, so I know it's going to be a D. And we have to figure out what we're adding. I think we said 6 there, so D equals 6 is what we would write. This one, we said what we're multiplying by each time is 1/5, so we write R equals 1/5. R because it's common ratio, 1/5 because that's the value. Okay, next. Okay, so here in this problem, you want to copy that in your notes, but here we're talking about recursive formula and explicit formula. So I need to give you those. So today we're going to focus on just the recursive and the explicit for arithmetic. So let me give you those. The arithmetic formula, arithmetic recursive, is a sub n is equal to a sub n minus 1 plus d. Now, don't let that formula confuse you. It's a lot less complicated than it looks. All this is saying, the term recursive means it's referring back to a previous term. And what this means here is a sub n, that's some term of the sequence, it's equal to a sub n minus 1. Well, a sub n minus 1 is the term right before the nth term, right? So if I have like 10 for n, a sub 10, a sub 10 minus 1 is a sub 9. A sub 9 is the term right before the 10th term. It's the 9th term. So that's all that's saying. So some term is equal to the term right before it plus the common difference. Well, that should make sense because we just said we take the term, we add on the common difference, and we get the next term. So that's all this formula is. Some term equals the term before it plus the common difference. Now, that formula we will identify, we will use a little bit, but it's actually not it's not real useful. So we won't use it nearly as much as we will use the arithmetic explicit formula. And explicit, again, it's a good name for it because it'll give us the explicit term that we're looking for rather than having to refer back to the term before it. So the explicit formula, again, starts off a sub n. Now it starts with the first term, a sub 1, and then I add on the d multiplied by the number of terms minus 1. So that's the formula. Okay, so now we're going to apply those formulas to this sequence. So we have 6, 9, 12, 15. Well, first of all, I'm kind of alluding to the fact that this is arithmetic because I'm only giving you the arithmetic formulas today. But you should double check and make sure. You'll have to first identify what kind of sequence is this. So I'm seeing 6, 9, 12. I'm seeing, yes, we're adding 3 each time. It is arithmetic. So because it's arithmetic, I'm supposed to write the recursive formula and the explicit formula. So here we go. Recursive formula, a sub n is equal to a sub n minus 1. That I don't plug anything in for. Then all I have to do is write plus d, and the d value is 3 because 3 is what we're adding on each time. That right there is the recursive formula. Explicit formula, a sub n equals a sub 1, which is the first term, which is 6, plus d we said is 3, times the quantity n minus 1. Now I want to leave n in my equation because otherwise it's not an equation if there's no variables. I do want to simplify that though. I don't want you to leave the unsimplified form. I want you to simplify. So we're going to distribute that 3 and combine like terms, giving us a sub n equals 3n, and then 6 plus negative 3 is positive 3. That is our explicit formula. Okay. Now, the last thing that this question asks for is for us to find a sub 30. Think about what that means. It's asking us for the 30th term. So I have to think here, would the recursive formula be useful or would the explicit formula would be useful? So looking at the recursive, if I plug in 30, then I need 30 minus 1, which is 29. I would need the 29th term in order for me to find the 30th term. Well, I don't know the 29th term. So the recursive formula is not real useful in this case. On the other hand, the explicit formula helps me know the explicit term that I'm looking for, which is the 30th term. So I can just substitute 30 in and do 30 times 3 and add 3, which gives me 93. So I write a sub 30 equals 93. And 30 is, or the 30th term is 93. So let's do the same thing on this one. 5, 9, 13, 17. So the first thing I'm going to do is identify what kind of sequence it is. 5 to 9 to 13. I can see that this is an arithmetic sequence where the d value is 4. So recursive formula, a sub n equals a sub n minus 1. And then I'm going to add on the common difference, which is 4. That's my recursive. Explicit, a sub n equals a sub 1, which is 5, plus the common difference, which is 4, times the quantity n minus 1. So a sub n equals 5 plus, distribute the 4, 4n minus 4. So if I simplify that, I'm getting 4n plus 1 is a sub n. That is my explicit formula. Now all I need is to find the 25th term, a sub 25. Again, if I tried to use the recursive, I wouldn't get very far because I don't know the 24th term. So I'm going to use the explicit, which says 4 times 25 plus 1, which gives me 100 plus 1, which is 101. So a sub 25 equals 101. Okay. Next. So I'm supposed to write the first 5 terms of the sequence. Well, I don't know the first term. I do know, I see this here, I see D, so that tells me this is an arithmetic sequence. Okay, so the easiest way to do this one, when you're only asked to find a few terms, I think it's easiest just to write out those couple terms. So I know the third term is 8, which means on the third line I'm going to put an 8. So from here, I want the terms in front of that, and I want the terms behind it, and I know it's arithmetic. So all I have to do is add 5 on to get the next 2, and subtract 5 to get the previous 2. And then that would just be our work for that. We're subtracting 5 and we're adding 5. Okay. Next. Find the first term of the sequence if a sub 16 equals negative 25 and d equals negative 2. This time again, I know because d, I know it's arithmetic, and I still don't know the first term, but there's a lot of terms, okay, because we have the 16th and we want the first. I do not want you to draw 16 lines and work your way backwards, okay, because there's so many. It was fine on the last one because we didn't have that many to draw, but you don't want to do that. And what if there were 100 terms? Are you going to draw 100 lines? Of course not. So what we'll do instead is we'll think about our equations and which one would be the most useful. Well, if you look at the 2 equations, the explicit formula involves the first term, and that's what I'm trying to find. So the explicit formula is what we want to use. So a sub n equals a sub 1 plus d times the quantity n minus 1. So I'm going to substitute what I know into that formula. So looking, do I know a sub 1? No, that's what I'm looking for. So I'm going to leave a sub 1. I do know d is negative 2, so plus negative 2 or minus 2 times the quantity n minus 1, but I also know n. I'm going to use 16 for n. And a sub n would be a sub 16. And actually, I'm going to write a sub 16, but I'm going to replace a sub 16 with its value. Because remember, that's saying the 16th term is equal to negative 25. So I want to put the value in for the 16th term, which is negative 25. I don't know the first term. I'm going to go ahead and subtract 16 minus 1 and get 15. So I have negative 25 is equal to the first term minus 30. And I can just add 30 to each side and get that the first term is equal to 5. And that answers the question. The first term is 5. Okay, last problem for the day. So here we have these terms, we have these sequences which are arithmetic, we're told that, and we want to find the missing terms. Well, this is similar to when you were finding median or the middle number. And what you did when you want to find a number that's halfway in between two numbers, when you're adding those numbers, is you average them, or what we call the arithmetic mean. So the arithmetic mean means I'm going to add these two and divide by 2. So that gives me 30 halves, which is 15. Once I know that that's 15, I can subtract 15 minus 6 to figure out that 9 is the common difference. So if I know the common difference is 9, I can subtract it from 6 to get negative 3. And now I can use 9 in the positive direction, add 24 to 9, and get 33. So that's how you'll approach problems like that. So we can do this one the same way. Again, it's arithmetic, so I can do the arithmetic mean to get this middle term. So if I add 1/2 and 5 halves, that gives me 6 halves. Well, 6 halves is 3. And I can take 3 and divide it in half, and that is my middle term. So I'm going to do that again to get the middle between those two. So 1/2 plus 3 halves is 4 halves, which is 2. And divide that by 2, and that's 1. And next, between 3 halves and 5 halves. So 3 halves plus 5 halves is 8 halves, which is 4. Divide 4 by 2, and I get 2. So that term is 2. So that's called the arithmetic mean. All right, so that takes care of the notes for today. So you're going to do these problems for tomorrow. Please stay on top of your assignments. This unit, it moves very quickly, and there are a lot of formulas to memorize. So it's really important that you do these problems, stay on top of your assignments, and then the more and more problems that you complete, you'll start to get those formulas memorized, which you're going to need to have memorized for the end of the unit. So stay on top of your assignment, get those problems done for tomorrow.